chapter 24, Antioxidants, page 425. Those who have the textbook, page 425. If anyone is joining late, please help them out with the page numbers. Those who have the new version of the textbook, your page numbers may slightly vary, so please check that. New page numbers or chapter number, please put it in the chat box. So, first, understanding what is oxidation. Oxidation, we can also call it as burning of the burning of burning of substances to give out energy. Okay. So at a cellular level, oxidation also takes place. Okay. You must be aware of electrons, neutrons, and protons. Okay. So oxidation is a chemical reaction in which atoms they lose their electrons. Okay. Neutrons, the nucleus, and the protons, okay, they are positively charged, they are in the center. Okay, they are in the center. But electrons, if you see, they are in the shells, they are revolving around the atom, they are in the outermost shells and all. Okay, there are different layers to it, different layers of shells. Okay, so majorly atoms lose the electrons which are at the outermost shells. Okay, electrons are negatively charged. These are the basic chemistry. Okay, so because electrons and protons they have opposite charges. Okay, they are attracted to each other in such a way that they will keep the atom stable. Okay, it's because there is something positive in the center and negative electrons are revolving around it. There is a magnetic force that is acting in between both of them, because of which electrons will not just randomly fly away, because there is something positive. The proton and neutrons are there in the nucleus. There is something positive that holds on to the electrons to keep revolving around it. Okay. Otherwise, if the nucleus was not there, if the positively charged nucleus was not there, there would have been nothing that could keep the electrons in their shell. Okay. So, but what happens that electrons get lost? It's usually a reaction. Atoms, when they react or when they come in contact with other certain substances, they lose the electrons. Okay. Then we have the redox reaction. Redox is reduction and oxidation. Together we call them as redox. Okay. Just like how we saw in oxidation, you are losing electrons. In reduction, you are gaining electron. Okay. So during any metabolic reaction, when something is losing electrons and something else is gaining electron, okay, there is a loss and gain. Both are taking place. So we call it as reduction, oxidation, redox. Okay. Whenever there is some metabolic actions taking place within your body, okay, at a biochemistry level, some metabolic activities are taking place, okay, some atoms will lose their electrons and those atoms are undergoing oxidation. Some atoms will gain electrons and those atoms are undergoing reduction reaction. Okay. So these are the two main reactions through which antioxidants can be understood. Okay. Is everyone seeing my screen or is somebody's video disturbing? Just let me know in the chat box. Is my screen being visible to all? Okay. So you can see here in oxidation reaction, there was one atom who lost their electron. This was oxidation. There was another atom. This lost electron may have gone and attached itself to a new atom. So that atom gained an electron. So it reduced. Okay, reduction reaction took place. Okay, so one is a reducing agent, one is an oxidizing agent. Okay, so this is how the redox reaction takes place. One will take their take the atom away, okay, from another atom. Atom A, atom B. B is taking the atom away from A. Okay, so the one who is taking the atom away or one who is undergoing reduction, they are the oxidizing agent. Don't get confused, okay? The atom who is undergoing reduction reaction, they are the oxidizing agent. Okay, the atom which is undergoing oxidation, they are the reducing agent. Okay, because their atom is getting their electron is getting reduced. Okay, so they are the reducing agent. So reduction reaction is the combination of oxidation and reduction. Okay, oxidizing agents, we also call them as free radicals. Okay, because they go to a normal stable atom. Imagine this situation, you will understand it better. Okay, this red color atom, consider this as a normal atom in your body, in your cells. Okay, this blue color oxidizing agent is a free radical. Okay, now this oxidizing agent will come to your healthy cells atom, take away its electron to stabilize itself. It will take away the electron to stabilize itself. Now, what is becoming unstable? What has lost an integral part of its structure? Your healthy tissue, your healthy cells atom has lost something, right? Now the cell is not as healthy as before because till now it was stable. Once its electron was taken away from the oxidizing agent, now it is unstable, right? So that is how reducing agent and oxidizing agent, we can put it into a example form in a human body. Is it clear to all now? So coming to free radicals, what are free radicals? See, the oxidizing agent is the free radical. Okay. So they contain one or more unpaired electrons. You can see here in the previous, just a second. You can see here, this oxidizing agent does not have one electron, one is missing, a pair of electron is missing. So this oxidizing agent is in search of that electron, from where it will get the electron. Okay, so they may have one or more than one unpaired electrons. Electrons want to pair itself. Okay, electrons want a pair, otherwise the atom becomes unstable. It goes on damaging things around it. Okay, they are highly reactive. Okay, anything that is highly reactive in your body, it will cause some destabilization. At a cellular level, it will cause some destabilization. Okay, so free radicals are these oxidizing agents which have missing pairs of electrons, and they are constantly in search of finding that missing spare electron from anywhere possible. Okay, so you can see here, this is a normal oxygen atom. Okay, when oxygen reacts with oxygen, has n number of uses in your body. Okay, at a cellular level, at each and every cell, oxygen is used up. Okay, some part of oxygen's electrons will be used up, some will be left. Okay, so when oxygen is getting used in your body, it may lose some electrons, and an unpaired electron will be created in the oxygen atom. Okay, now this oxygen atom will go and search from where should I find this electron to stabilize myself. Okay, it will create a chain of reaction. This oxygen atom will damage one cell. That cell will become a free radical and damage the other cell. More free radicals will be created. It will go on damaging cells after cells. Okay, it will create a chain reaction like this. One oxygen atom will try to grab the electron of another oxygen atom. Now the second oxygen atom became unstable. They will grab the electron of a third oxygen atom. The third one will become unstable. So it goes on like this. Okay, there is a set of chain reactions that is taking place. And it will generate free, new radicals by chain reaction. Okay, more and more free radicals will be created through chain reactions. Okay, they can cause damage to biomolecules, cells, tissues. So now earlier we had only one oxygen atom, but because of the chain reactions, many damages took place in the light of those chain reactions. Okay, so at a cellular level, at a tissue cellular level, damages have begun. Okay, the cell wall or the cell membrane, you can see here, because of this chain reaction, the cell membrane got disrupted. Cell wall, cell membrane got disrupted. Okay, and if the cell membrane is disrupted, what will happen? Cell wall is the structural integrity of your cell. Okay, it holds the content of your cell together. So just imagine the cell wall, the cell membrane, it got eroded. What will happen? The permeability will be lost. What should enter the cell? What should exit the cell? Control over that will be lost. The control of on permeability will be lost. Anything can enter the cell, cause damage. Important things from the cells can leave the cell, cause some deficiency. Okay, these things can happen. Am I audible to all? See, why the free radical has caused because of human body's biochemistry. Any reaction that takes place, free radicals are the byproduct of it. Okay? When a reaction between various substances in your body is taking place, electrons get displaced. So that's how free radicals are existing. Okay? Free radicals will always exist as long as your body functions. As long as biochemical reactions take place in your body, free radicals will exist. 1 second. Just give me a moment. So this is how free radicals are formed. Okay, anything that has lost their electron, any atom, any substance. Okay, substance means go to its atomic structural level. If they have lost their electron, they have unpaired electrons. That is a free radical. Okay. Here they have just shown oxygen because oxygen is the most common free radical. So this is how antioxidants will come to rescue. Okay. Antioxidants. If you remember the name, oxidizing agent, okay, against antioxidants. You see how the name is formed. They are against this oxidizing agent. They are against the free radicals. So antioxidants are like these self-sacrificing substances. Antioxidants have lot many electrons. And they are ready to give those electrons up. Okay? They will give electrons, they will distribute electrons towards the free radicals to stabilize them. Once the free radicals have got the electrons that they need, they will no longer cause further damage. Okay? So, antioxidants are these self-sacrificing substances. They will neutralize the free radical. Okay? Free radicals are not that bad until they lost their electrons. Okay? Any atom that have lost their electron, it becomes unstable, highly reactive, highly damaging. But when you give it back the electron that it has lost, it goes back to normal. It just becomes a free floating substance, causing no damage. Okay? So that is the role of antioxidants. Antioxidants have these electrons with them in their outer cells. Outer shells, they have a lot many electrons. They are readily they are giving it away without getting unstable by themselves. Okay, so that is the specialty of antioxidants. Is it clear so far? So far, is it clear? So, coming to free radicals versus antioxidants. Free radicals, as we have seen, they are produced by the oxidation process, something that have lost the electron. In oxidation, you lose electron. In reduction, you gain electron. Okay. So free radicals are produced during the oxidation process, and oxidation takes place at every cell level. Each one of your cells in your body, you have millions, trillions of cells in your body. At each one of those cellular level, oxidation is a process that takes place. Okay, so free radicals are generated at your cellular level. Okay. It helps your immune system to neutralize virus and bacteria. Free radicals. Okay, free radicals can also have this benefit that it will go and attack virus and bacteria for that electron, because free radicals does not have the brain what to attack, what not to attack. It just wants to stabilize itself. It just wants that electrons that it has lost. It wants it back for stability. It doesn't care if it is a virus, if it is a bacteria, or if it is a normal healthy tissue or cell. Doesn't care. Okay. So that is the only benefit of free radicals, that it can also neutralize virus and bacteria by taking their electrons. Okay. And if a virus or bacteria has lost their electrons to free radicals, they don't become that active to cause any infection or diseases. Right? So free radicals can attack or neutralize bacteria or virus in the process of finding stability. Okay. Free radicals, they just have one job. They want to steal electrons from stable molecules. Okay. And once they steal the electron, just imagine one free radical. It has two or three unpaired electrons. Okay. It could only find one electron from a cell. It is still unstable. And now the cell has also become unstable. It found another electron from another cell. A second cell got unstable. Third electron it got from third cell. Okay. Third cell has become unstable. By the end, free radical must have stabilized. But in that process, 3 to 4 cells have become unstable. Okay. So one free radical, in the process of stealing electrons from here and there and here and there, they are creating more free radicals. Is it clear to all? So it causes cell tissue damage. It leads to many diseases. Now, over a period of time, if you imagine certain types of cells, certain part of an organ where more free radical is created, more tissue damages are taking place, cellular damages are taking place over a period of time. Definitely, from a cellular level, it will become a tissue level damage. From a tissue level damage, it can become a organ level damage, okay, and cause a disease condition. So this is where antioxidants will come for your rescue. Okay, they stabilize the free radicals by giving up their own electrons. Okay, as I mentioned earlier, antioxidants, they have not many electrons on their outer cells. They are readily giving it up without becoming unstable on their own. That is the potency of antioxidants. Okay, and we get the antioxidants from fruits, nuts, vegetables, even dietary supplements. Okay, sources of antioxidants we'll see. But I hope it is clear, like antioxidants are something you hear everywhere nowadays. Okay, they have completely bastardized the name of antioxidants. They are selling anything and everything under the name of antioxidants. Okay, but as a consumer, you should be aware of what antioxidants are, the names of certain antioxidants, so that you don't get fooled by these marketing gimmicks. Okay, now you know what antioxidants are, what they actually do. Okay, they are not that miraculous or something. They have a specific job to do. Okay, that is to stabilize the free radicals. Once the free radicals are stabilized, at least they will not cause more damage. Okay, antioxidants will not just stabilize the free radicals, it can also stabilize the tissues and cells that free radicals may have damaged by giving electrons to those substances as well. Okay. So sources of free radicals. Wherein all free radicals are, yeah, blue colored foods, usually you have very few blue or purple colored food, but blue and purple colored food is also associated with a good amount of antioxidants, as well as colored food. Okay, pigmented food pigments, natural food pigments are associated with high amount of antioxidants. Okay, so from where do we get free radicals? Everywhere. Okay, at every cellular level, antioxidants can be produced. So you have endogenous sources, leakage of electrons from transport chain in mitochondria. Okay, so these all are more biochemistry type of answers. You don't have to mug up these. Okay, endogenous sources means within your own body. How much ever healthy you are, how much ever diet conscious you are, how much ever physically active you are, free radicals will come to you, will be produced within you through these areas. Endogenous sources means because of the doing of your own body, because of your own cellular activity. Okay, free radicals will be produced. So leakage from electrons transport chain in the mitochondria. Okay, in mitochondria, oxygen will be used up, glucose will be used up for energy. And wherever oxygen is getting used up, oxygen is getting unstabilized. Its electrons are getting broken down, taken away. So those electrons can leak out of mitochondria, go inside the body of the cell, cause some damage. Okay. Then in endoplasmic reticulum and all, these are the structures of the cell. Okay, cytochrome P4, 415, endoplasmic reticulum. These are just names of certain free radicals, which is there in everyone's body. Endoplasmic reticulum is very close to the nucleus of the cell. Okay. The degradation of purine nucleotides to uric acid. This is from the DNA, your DNA and RNA. Okay. Your DNA and RNA has nucleotides. When new DNA, RNA has to be formed, old ones, okay, when they undergo degradation, that also becomes a free radical. If there is an interaction between iron and copper, okay, iron and copper within your body, that can lead to free radicals. Peroxisome, respiratory burst. Okay, respiratory burst is uh, cells burning up themselves. Okay, it is kind of an apoptosis, cell suicide. Okay, so in that also free radicals are formed. Cell suicide can take place because of various reasons. If the cell is becoming cancerous, if the cell is getting some infection, it can undergo apoptosis to prevent the spread of infection or to prevent the spread of cancer. Now come from the exogenous sources, outside sources. So far we have seen the internal sources. Because of your own body's reaction, how free radicals are formed. From exogenous sources, when you take some medications like drugs and certain chemicals, you are exposed to certain chemicals. Okay, that can to a degree that it can cause liver damage and all. Okay, being posted in a very polluted city or being born and brought up in polluted cities. Okay, that can also cause this kind of damages. Just give me a second, 1 second. So drugs and chemicals, high dose can cause liver damage as well. Then peroxidization catalyzed to lipoxygenase in platelets and leukocytes. Whenever you are getting hurt, some traumatic injury is taking place, or some infection is taking place, your platelets and leukocytes that are white blood cells, okay, they are active. Okay, when they are having an interaction with these foreign bodies, that can lead to free radical creation. Okay, UV radiation, gamma radiation, okay, that can also lead to uh, being exposed to UV radiation, being exposed to infrared gamma radiations, smoking, environmental pollution. Okay, these all are the reasons how external factors, your environmental factors, can cause production of more free radicals. You already have production of free radicals, but these situations can aggravate the production of free radicals in your body. Okay. Next is the antioxidants defense system. So again, you have two types, endogenous and exogenous. Okay. Just like how you have free radicals, which are endogenous, exogenous, like some free radicals are produced in your own body by itself because of various chemical reaction, and exogenous free radicals because of your environment that you live in, that is causing free radicals, production of free radicals. Okay. The same situation, same principle will apply to antioxidants also. Your body also produces antioxidants. Okay, your body is capable of producing non-enzymatic and enzymatic antioxidants that are there to take care of free radicals on its own. Okay, and then you have exogenous antioxidants that you usually get from food. Okay, all the exogenous antioxidants are usually from food. Endogenous, you have two types, enzymatic, non-enzymatic. Okay, certain enzymes, they work as antioxidants like catalase, superoxide dimutase, glutathione peroxidase. These are enzymes that are produced in your body. They also act as, they have a specific role, but they also act as antioxidants. Okay. Then in endogenous non-enzymatic, you have glutathione produced in your body, thioredoxin, ubiquinone, uric acid, lipoic acid, bilirubin produced by your liver. Okay. They all have antioxidant capabilities. They are produced in your own body. Okay. Exogenous antioxidants are the ones you get from food. Vitamin A, C, E, K, they have antioxidant property. Beta carotene, okay, it's a type of vitamin A from plant sources, beta carotene, that gives that yellow color to the yellow, red, orange color to the food. Ubiquinone is available from plant sources as well. Polyphenols available in tea and coffee. Okay. Flavonoids, it is available in tea. Phenolic acids are available in coffees and all. So polyphenols are from the tea, coffee, beverages, cocoa and all. Resveratrol, that is available in the red grapes. Okay, in wine, red grapes. Curcumin, can you guess from where do we get curcumin? Yeah, it is from turmeric. Okay, so these are the categories of your antioxidant defense system. Is it clear to all? So functions of different antioxidants are given in detail, that you don't have to just read through it. You don't have to mug up anything from that. Okay, just understand the names of these antioxidants, the types of antioxidants, okay, the sources, names of it, that is more than enough. The pathways in which they function is not necessary. So coming to antioxidants and disease, immunity and aging. So that is the first function. The more antioxidants you have in your diet, or the more antioxidants your body is able to produce, your aging process slows down. Okay. Antioxidants can also help boost your immunity. Okay. Especially vitamin A, beta carotene, vitamin E, vitamin C, vitamin B6, folic acid, iron, zinc, selenium. Okay. These are the nutrients that are known for their antioxidant effects, just to promote your immunity and to delay aging. For delaying aging, vitamin A is the most important one. Vitamin A and vitamin C, most important antioxidant. Especially your skin, the way how you look and all, to have healthy skin, wrinkle-free skin, vitamin A, vitamin C are the antioxidants required. And also to cure certain chronic diseases like asthma, okay, bronchitis, asthma, their incident rate also reduces once you consume more salads, green vegetables, or any antioxidant rich food. The incident rate of these disease conditions goes down. Then cataract. Cataract also is a disease condition that takes place because the prolonged oxidative stress is there. Okay, prolonged oxidative stress is there in your eyelids. Eyes get cloudy. Okay, And because of this regular damage on the eyes, cloudiness of the eyes, the person may have cataract. Okay, again and again, free radicals are going and attacking the lens of the eyes. It will become cloudy. Okay, the structural integrity of the lens will be lost over time. Okay, it loses its focus power and all. That's how cataract happens. And also, if you have uh, too much of exposure towards UV light, that can also cause high incidence rate of cataract. And it is also seen that cataract is usually high in people who have deficiency in certain micronutrients like riboflavin, copper, zinc. People who have low zinc, copper, riboflavin in their body, they are at higher risk of developing cataract, especially riboflavin deficiency. It's a vitamin B12, okay? B3, I think so. If you have riboflavin deficiency, high chance that you will get cataract. So having high levels of vitamin C, E, carotenoid, okay, that can delay the development of cataract. And also, if you take enough amount of omega-3 fatty acids, that can also improve your visual acuity. Inositol is also found to be helpful. Coming to cancer, there are different antioxidants associated to different types of cancer. Okay. For example, consuming more beta carotene will reduce the risk of stomach cancer, cervical cancer, esophageal cancer, throat cancers. Vitamin C will reduce the risk of GI tract cancer, cervical cancer, cardiovascular diseases as well. Vitamin E can reduce the risk of oral cancers, pharyngeal cancer. Selenium can reduce the risk of esophageal and stomach cancer. These associations are found. So again, when free radicals are able to damage cells at their DNA level, that's when accumulated damages, not that one free radical randomly caused a damage in your cell, in the DNA, and you got cancer. It's not like that. It is accumulated damage. Damage over damage, repeated damage that is taking place over a period of time. That's how mutation will take place. DNA mutation will take place and cancer may form. And also National Institute of Nutrition, Hyderabad, they conduct a lot of studies in these areas. So they have found that curry leaves, curry patta, okay, that extract can prevent certain cancers. Okay, that is a potent antioxidant. Extract of curry leaves. Then you have protein energy malnutrition. Here as well, children who are low on copper, they are at a risk of developing protein energy malnutrition. Recurrent infections may take place. So correcting the copper situation in children can prevent protein energy malnutrition. There are certain neurological conditions like Alzheimer's, Parkinson's. Okay, they have found a relation between Alzheimer's and folate, vitamin C, beta carotene. Okay, they seem to be the best protective nutrients against Alzheimer's. They can delay the cause of Alzheimer's. Along with vitamin B6 and B12. Also in Parkinson's disease, That is also a progressive neurological disease. Day by day, as the time goes on, Parkinson's get worse and worse. So supplementation of L-dopa therapy, okay, that can also affect, that can at least delay the progression of Parkinson's. Multiple antioxidants can be given to delay the progression of Parkinson's as well. Then cardiovascular disease, when the low density lipids, okay, LDL cholesterol, bad cholesterol, they accumulate, they cause cardiovascular diseases. So for people who have a history of cardiovascular diseases or family history of cardiovascular diseases, consuming selenium, vitamin C, vitamin E, beta carotene, okay, these can have antioxidant roles in your body, which can prevent or reduce the risk of cardiovascular diseases. So, consuming polyunsaturated fatty acids, that is vegetable oils, avoiding saturated fatty acids, avoiding animal fat is good to prevent cardiovascular diseases. Also, effect of exercise. The more you exercise, the effect of free radicals can be reduced. Okay. Regular physical exercise will enhance the way how antioxidants are able to defend your own body. Just by taking antioxidants, it's not enough. You have to be physically active as well so that the antioxidant defense system is strengthened in your body. Okay. So, what are the requirements of antioxidants? At least 500 gram per day of fresh fruits and vegetables. Vitamin E from very little amount of vegetable oil is also enough for enough requirement of antioxidants. Okay, at least if you are taking 500 gram of fruits and vegetables combination, in different times definitely. But if you see at your meal whole together, if you have taken at least 500 gram of fruits and vegetables throughout the day, that is a good enough quantity to ensure that you have taken enough amount of antioxidants. So sources of antioxidants, whole grains and pulses, rice, jowar, okay, rajma, bajra, and maize. Maize, that is makka, and ragi. Ragi has the highest antioxidant content. Okay, then you have makka, that is maize, then bajra, jowar, rice, rajma. Okay, these are the cereals and legumes that have high amount of antioxidants. Ragi has the highest phenolic content and the antioxidant activity among all the cereals and pulses. Soya bean as well. They have isoflavonoids, phytoestrogens. Nuts and oil seeds, peanuts, okay, pink skin of the peanuts, they have resveratrol. Walnut is also has the highest amount of antioxidants among all the nuts and seeds. Walnuts, brown raisins, peanuts, so they have the highest amount of antioxidants. Then whey protein, if you're taking whey protein, they also have antioxidants that can increase your tissue's glutathione levels. Fruits and vegetables, carotenoids, resveratrol, polyphenols, flavonoids, phytoestrogens, terpenes. Okay, these all different types of phytochemicals, antioxidants are found in fruits and vegetables. A list is shown in page number 445, table 24.10. You can check that list. Different types of carotenoids and which fruit and vegetable is rich in that they have mentioned. Okay, you can check that later. Lycopene is there in tomatoes, but lycopene, how you can utilize it? Only once you have cooked your tomato. Tomatoes has to be slightly cooked. Only then it can you can your body can use the lycopene. Seed oils are not that bad. Okay, seed oils are good sources of polyunsaturated fatty acids, good for heart health. Okay. Then you have oils, rice bran oil, that has the highest amount of antioxidants, palm oil, sesame oil, olive oil. So these are the seed oils, vegetable oils, which have good antioxidant capabilities among oils. Okay. Among spices, clove. Now, okay, clove has the highest antioxidant level. Then you have cinnamon, then star anise, then turmeric, mace, nutmeg, turmeric. Okay, so these are the spices which have highest amount of antioxidants. The highest is clove. Okay, the most highest antioxidant levels in spices is found in cloves, and cinnamon, and star anise, mace, nutmeg, turmeric. Coming to tea, they have enough amount of flavonoids. Antioxidant property of tea is through the presence of flavonoids. The antioxidant present in a cup of tea is much more than the antioxidants present in a cup of orange juice. Okay, it is more potent. Black tea and green tea both have antioxidants, and more consumption of green tea and black tea can reduce the risk of coronary heart disease. Then coffee has polyphenols. Coffee, the polyphenols present in coffee is the only one well researched. More than tea, it is the polyphenols present in coffee which is well researched, which is much more evidence based. Okay, in comparison to tea, coffee is much more evidence based. Caffeine present in the coffee can also reduce the risk of liver, pancreatic, and colorectal cancer. Filter coffee also has more antioxidants. Filter coffee used in South India, which has the mix of that chicory and Arabia, coffee Arabia. Okay. Then red wine, the red grapes, coffee without milk. Black coffee is much better than milk coffee. Then red wine, it has resveratrol, which can delay aging process. That is what it is claimed. Okay, that comes from grapes, the skin of the grapes, red grapes. That can also reduce your cholesterol levels. Then certain herbs used in food, basil, dill, fennel leaves. Okay, am I audible to all? Am I audible to